Next up is the next tool on the list, which is the Trim Surfaces by Curves. Now, you've already used this tool if you completed the kayak exercise in Module 8. However, a little more information will be quite helpful. As you know, the tool punches a hole in a surface by projecting a cutting profile through the surface. There are some restrictions. For example, the cutting surface must be a closed element, but it cannot be a B-spline surface. Now, so far as the options are concerned, there are quite a few. Look in the tool settings window. Direction can be orthogonal, view, vector, or normal to a surface. Now, orthogonal means that the direction of cut is normal to the cutting profile. Now, normal simply means the axis, essentially, of the cutting profile. Now, since normal is in one direction only, you may need to reverse the normal direction before a trim will take place. You can use the Change Normal Direction tool, as we'll see a little later on, to change the direction. If we use view, then the cutting is normal to the view, in other words, along the z-axis of the view. With the vector, you define the vector by 2 data points in the view. And normal to surface, this is normal to the surface to be trimmed. And the method we can use, we can trim the surface, where the profile will simply trim a hole in the surface that we're interested in. We can split the surface, where the surface is split into 2 parts. Now, the split surfaces will remain in place, and you can move them with the Element Selection tool if necessary. We can project a curve onto the surface, but the surface isn't trimmed at all. It's merely a curve placed upon the surface. And we can impose onto, which again projects a B-spline curve onto the surface and cuts the surface to create a boundary. We can keep the original profile if we want, or we could convert the surface to a B-spline surface after the trim has taken place. Let's try a few examples, and we're going to use this one. So I'm going to zoom that one out as well. And I have a couple of profiles here which we're going to use to trim this surface. So I'm going to leave orthogonal on, and I'm going to trim the surface as the method. So select the surface to be trimmed first, then select the profile, and simply data point and data point. And we have a nice little hole drilled through the surface. Let's try the next one. Data point, and data point, and accept. And in this case, we've trimmed the edge too, because the profile is directly above the edge of this curved surface. Let's undo. Let's do a split surface. Same process. Select, select, and select. And nothing appears to have happened, but if I start my element selection, you'll see that we do have a surface here, and I can drag that off. So I have a surface which fits nicely into there, and I can use that for other purposes. That's fairly straightforward. Let's undo that. Let's change the method to project curve. Try this again. Select the surface, select the profile, data point. And we see that we have a curve projected onto the curved surface. And I can drag that off too. And that gets me a curve in the perfect shape of the yellow surface, which again I can use for other purposes. Let's undo that. And try the last one, which is impose onto, select, select, and select. And what we see is apparently nothing, but what I have to do is go back to my wireframe view, and we can see the profile imposed upon the surface. So what we see now is actually part of the surface. Again, this could be quite useful for locating something else which is being attached to this surface. Try some examples with this yourself and use some of the other profiles in this drawing if you wish.